Chapter 8a Review. Question number 1. We're given the rational expressions x squared minus 4x plus 3 over x squared plus 3x minus 4. And you are asked to simplify these rational expressions. So something I would like to keep in mind when it comes to quadratic equations. Think about, is there any way you can factor these quadratic equations into its factor form? So factor form means that I'm looking for numbers that multiply to the certain number. And that certain number, the clue comes from the constant. So for the top one, I'm looking for two numbers. When you multiply together, you have the 3. And as you add these two numbers together, you have negative 4. So what are the two numbers that are possible? Make up the factors of 3. So I'm thinking of negative 3 and negative 1. Because negative 3 times negative 1 gives me positive 3. Negative 3 plus negative 1, that's negative 4. How about the bottom one, the denominators? So repeating the same information, I'm looking for two numbers. When you multiply together, you have negative 4. And as you add these two numbers together, you have positive 3. So I'm thinking of x plus 4, x minus 1. So again, 4 times negative 1, you have negative 4. 4 plus negative 1, that's positive 3. So now, do you see that the x minus 1 and x minus 1 are exactly the same? So when I have the same factors, top and bottom, I can go ahead and reduce them. So notice once again, I'm using the word reduce. So the whole expression can be simplified down to x minus 3 over x plus 4. One more thing, make sure you exclude the x values which will make the denominator equal to 0. So since we have the denominator in its factor form, all we have to do is set the factor. So each of the factors equal to 0. Each of the factors equal to 0. From there, we can exclude the x values that are making the denominators equal to 0. Exclude. Make sure you exclude these values. So our x cannot be negative 4, nor can it be positive 1. Question number 2. You have x squared plus 2x minus 3 divided by x plus 4. Multiply 4x plus 16 divided by 2x plus 6. So following the same information from the first example, I'm looking for two numbers. When you multiply together, you have negative 3. As you add these two numbers together, you have positive 2. So what are they? So I'm thinking of x plus 3 times x minus 1. Because 3 times negative 1, that's negative 3. 3 plus negative 1, that's positive 2. At the bottom, the denominator is a linear term, so nothing I can do about it. Just repeat by copying it again. For the second term, so take a look. Are there any common factors between 4 and 16? Can I factor out the 4? So 4 times x, that's 4x. 4 times 4, that's 16. How about the denominators? 2 and 6. So 2 can be factored out, followed by x plus 3. You can always check it by using the distribution property. 2 times x, I have 2x. 2 times 3, I have 6. So now take a look. What do you see that they are the same, top and bottom? So the clue is top and bottom. So do you agree that this x plus 4 are the exact same thing, top and bottom? x plus 3, exact same thing. And 4 divided by 2, so I can reduce it down to 2. So what are the terms that's being left? we have 2 times x minus 1 over 1, which is exactly the same as 2 times x minus 1. One last thing, don't forget to exclude the x values will make your denominator equal to 0. So my x plus 4 cannot be equal to 0, which means my x cannot be equal to negative 4. X plus 3 cannot equal to 0, which means that my x cannot equal to negative 3. Question number 3. We have the division problems. Remember I said about dividing is all about taking the reciprocal of your divisor, change the operation from dividing into multiplications. So now let's take a look. The question itself is x squared minus 2x minus 8 over x squared minus 2x minus 15 divided by 2x squared minus 8x over 2x squared minus 10x. So first thing, I'm going to take the reciprocal of my divisor, change the operation from dividing into multiplying. So I'm going to take the bottom of my divisor, flip it to top. I'm going to take the top of my divisor and flip it to bottom. That's the reciprocals. Change the operation from dividing into multiplying. Then I'm going to follow the exact same procedure we did for multiplying. So are there any common factors I can reduce? So this has the technique of your factoring fish comes in. So I may factor the top of the first term into x minus 4 times x plus 2. For the bottom, I factor it into x minus 5 times x plus 3. Don't forget, we already changed the operation to multiplication, so I'm going to follow that. 2x squared and negative 10x, I'm going to factor out 2x. That's the greatest common factors between the two terms. And then I have x minus 5. The bottom, I have 2x as the common factor, and I factor into 2x times x minus 4. At this step, I can go ahead and reduce if there's any common factors. So x minus 4, x minus 4, x minus 5, x minus 5, 2x over 2x. So these are all the common factors, the same top and bottom. So I can go ahead and reduce them. I am left with x plus 2 over x plus 3. And what are the numbers I have to exclude at this point? So my x cannot be 5, nor can it be negative 3. It cannot be 0. Anything else? That's it. So our final answer is going to be x plus 2 over x plus 3. And our x values cannot be 5, negative 3, or 0. Number 4, we're going to do rational expressions, addition, subtractions. So I have x over x minus 1 minus 3 over x plus 2. So take a look. Do you have the same denominator, top and bottom? So obviously x minus 1 and x plus 2 are not the same thing. So what do I do to find the least common denominators? Remember I said when they are not the same, what's the simplest way to find the least common denominator? So I'm going to multiply. I'm going to simply multiply each other. So x minus 1 is going to multiply x plus 2. And if I multiply something to the bottom, I'm going to multiply it to top. X plus 2, I'm going to multiply x minus 1. So again, top and bottom. So now do I have the same denominators? So it looks like I have the same denominators. So I can go ahead and copy the denominators and then go ahead and add or subtract. In this case, we have the subtractions. But don't forget to distribute. I have x times x so that's x squared. X times positive 2, so that's 2x. Remember I mentioned something to you about subtracting? Make sure you distribute this subtraction sign to both terms in the second parenthesis. You're basically multiplying negative 3 to x. That is negative 3x. Negative 3 times negative 1, which is positive 3. So many students will make mistake on this positive sign. So double check on it. Negative 3 times negative 1 is positive 3. So now we can go ahead and simplify like terms. We have x squared minus x plus 3. Don't forget to exclude the x values, make your denominator equal to 0. So in this case, my x cannot be 1, nor can it be negative 2. Number 5, rational expression addition. We have 3x minus 1 over x plus 4. Add negative x over 2x plus 8. So does the denominator look the same to you? So let's take a look. We have 3x minus 1 over x plus 4. If I factor out the common factors between 2 and 8, so I have 2 times x plus 4. That's the denominator for second term. So it's fairly easy for me to do this question. So now I have the second term, 2 times x plus 4. First term has the denominator of x plus 4. So what would be the least common denominators? If I multiply the first term by 2, the denominator portion by 2, multiply the top by 2, would I have the same denominators? Of course, I will get the 2 times x plus 4. Once I have the same denominators, then I can go ahead and add the numerator, add the top. 2 times 3x, so that's 6x. 2 times negative 2, that's negative 2, minus x. Collect like terms, simplify if you can. 6x minus x, so I have 5x minus 2. At the bottom, you can keep your denominators just like 2 times x plus 4, or you can choose to distribute it, 2x plus 8. They're the same thing. Don't forget to exclude your x values, make your denominators equal to 0. In this case, my x cannot be negative 4. Question number 6. X squared minus 1 over x squared plus 3x minus 18. Subtract x plus 1 over x minus 3. If you have the temptation of multiplying the denominator because they look different at the very beginning, then you will run into the situation of multiplying a quadratic x squared to a linear x to the first power, making your denominator into x to the third power. You can definitely do that, but it's going to make your life a lot harder. Then, if I try to simplify it from the beginning, thinking about what two numbers, when you multiply together, you have negative 18, and as you add these two numbers together, you have positive 3. To see if I can factor the quadratic equation for the first term denominator into something that I can recognize for the second term. And it turns out, yes, indeed, I have the x minus 3 as the common factors. So what I need to do is just multiply the second term by x plus 6, top and bottom. Then I will have the exact same denominators for both of them. Agree? And that's what I'm going to do exactly here. Once I have the same denominators, then I can go ahead and add, subtract the top part. So my denominator, least common denominator in this case is x plus 6 times x minus 3. Now I have the same denominator, so I can go ahead and subtract x squared minus 1 Don't forget we have this subtraction sign here, so you have to distribute to every term. X times x, that's negative x squared. X times 6, that's negative 6x. 1 times x, that's negative x. 1 times 6, that's negative 6. Are there any like terms that you can collect at this point? So notice that each time I'm just copying my denominators because that's the least common denominators. X squared and x squared. So that cancels. Negative 6x minus x, that is negative 7x. Negative 1 minus 6, that's negative 6. I'm sorry, negative 7. What are the numbers we have to exclude from our x values? X cannot be negative 6, nor can it be positive 3. So make sure you exclude these two numbers. Question number 7. We're asked to solve for the x. This is an equation now. X squared plus x minus 12 over x plus 4 equals negative 10. So again, when it comes to equations, you can solve the exact x values. So what's the restriction? Don't forget to put on your restriction as your very first step. What are restrictions? Those numbers that will make your denominator equal to 0. So I think at this point you should know my x cannot be negative 4. Make sure you exclude these numbers from the beginning. Next, we have, so your numerator is a quadratic form. Can you factor it? I'm thinking of x plus 4 times x minus 3. X plus 4 at the denominators. So is this x plus 4 top and bottom exactly the same? Yes, they look the same, so you can go ahead and reduce them. Now what are we down to? We have x minus 3 equals negative 10. Add 3 to both sides. We have x equal to negative 7. So this negative 7 is not the same number as negative 4, so we are safe. But make sure you plug the numbers back into your equation to check it, meaning that your job is to make sure negative 7 squared plus negative 7 minus 12 divided by negative 7 plus 4, is it equal to negative 10? So make sure you do your check, as I'm trying to emphasize over and over. Not because you come up with a number that's going to be the correct answer. Always check it by plugging the numbers back into the equations. Question number 8. We have x squared plus 3x minus 18 over x minus 3 equals negative 4. So what's the restriction for this one? So take a look at your denominator, x minus 3, set it equal to 0. That gives us x cannot be 3. So now, converting the numerator, the top portion, into its factor form. So I'm looking for two numbers. When you multiply together, you have negative 18. And as you add these two numbers together, you have positive 3. So I'm thinking about x plus 6 times x minus 3. So with this form, it's very obvious. X minus 3 and x minus 3, they're exact same factors, so I can go ahead and reduce them 1 over 1. I'm left with x plus 6 to the right hand side. So x plus 6 equals negative 4. So my x would be subtracting 6 to both sides. X would be equal to negative 10. So our solution for this one is x equals to -10. Question number 9, x squared minus 25 over x plus 5 equals 6. So you might be wondering, how come the quadratic term at the numerator on top does not have the linear term? So remember I said something about x squared plus 0x minus 25. So you can treat this question same way like this. I'm looking for two numbers. When you multiply together, you have -25, and as you add these two numbers together, you get 0. So how could two numbers add up together equal 0? They would have the same value, but opposite in signs, right? So I was thinking about x plus 5 and x minus 5. Plus 5, minus 5, same value, but different in signs. And positive 5 times -5 equals -25. So now I have x plus 5 over x plus 5. They're exactly the same thing, so they can be reduced down to 1 over 1. I'm left with x minus 5 equals -6. So what's my x value? Plus 5 to both sides, so my x would be equal to -1. Don't forget our restriction. So the restriction would be my x cannot be -5. And since -5 and -1 are not the same number, so our answer should be x equal to -1. Again, you should check your answer at all time by plugging it back into the equation, which is -1 squared minus 25. Is it equal to over -1 plus 5? Is this equation equal to positive 6? So you should do the check yourself. Question number 10. 1 over x minus 5 equals 7 over 2x. You have a fraction equals a fraction. Don't forget to set your restrictions. So here we have x cannot equal to 5, nor can it be 0. If you plug these two numbers in, you don't make either of the denominator equal to 0, which is a big no-no. Since it's a fraction equals a fraction, we can use the cross multiplications. 1 times 2x equals 7 times x minus 5. Cross multiplications. 1 times 2x, that's 2x. To the right hand side, 7 times x, we have 7x. 7 times -5, we have -35. Subtract 7x to both sides. That gives us 2 minus 7, which is -5x. 7 minus 7, that's gone. -35. Divide both sides by -5. So -5 divided by -5 gives me 1x. -35 divided by -5, that's positive 7. And 7 does not equal to 5 or 0. So the answer is x equals 7. Don't forget to do your checkings. Always plug your answers, your finals, back into the answer to check it, whether your equation is correct or not, true or false. Question number 11. X plus 12 over x equals 7. So what's the restriction? By now, you should be very comfortable working this out. Your denominator can never be 0. So x can never be 0 in this particular case. Next, what's the denominator? What's the least common denominator for this term? So that's x over 1 plus 12 over x equals 7. What's the least common denominator between 1 and x? Is it going to be 1 times x? So let's go ahead and multiply everything by x. X times x, that's x squared. 12 times x divided by x, so x and x get reduced from each other. To the right hand side, you multiply the same thing, times x. So 7 times x. Now let's move the 7x to the left hand side by subtracting 7x to both sides. So I have x squared minus 7x plus 12 equals 0. Is this the quadratic equation we've been working on so far? Use your quadratic fish if you have to. I'm looking for two numbers. When you multiply together, you have negative 12. And as you add these two numbers together, you have you multiply these two numbers, you have positive 12. As you add these two numbers together, you have negative 7. So I'm thinking about negative 4, negative 3. Negative 4 times x, that's negative 4x. Negative 3 times x, that's negative 3x. Negative 4x plus negative 3x, I have negative 7x. So this matches up the linear term. So I can write my factors diagonally by x minus 4 times x minus 3. So what are my x values? X equals to 4 by setting this factor equal to 0. X equal to 3 by setting the second factor equal to 0. Always do your check by plugging the numbers back in to the equation. Does 4 plus 12 divided by 4 equals 7? And does 3 plus 12 divided by 3 equals 7? Always do your check. Number 12, negative 2x over x plus 2 plus x over 3 equals 4 over x plus 2. So we have two fractional expressions on the left hand side. What's the least common denominators between x plus 2 and 3? They don't look the same. So can I just multiply one another? X plus 2 times 3. So I have to multiply my numerator with 3. How about the second term? So I'm going to multiply x plus 2 to the bottom. I have to multiply that to the top as well. So we were just dealing with the left hand side. For the right hand side, I'm copying it again. So now do I have the same denominators for both terms on the left hand side? Of course I do. Now I can add the numerators, the top. So negative 2x times 3, I have negative 6x. Don't forget to distribute when it comes to parentheses. X times x, that's x squared. X times 2, I have 2x. So again, the right hand side stays the same. So now I don't like to work with denominators, so what should I do? I'm going to multiply both sides by 3 times x plus 2. So let's go ahead and multiply both sides by 3 times x plus 2. 3 times x plus 2. To the left hand side, 3 and 3 get reduced. X plus 2 get reduced. So we are left with x squared. Negative 6x plus 2x, that's negative 4x. The right hand side, x plus 2 get reduced. So now you are multiplying 4 times 3, which is 12. So following the same pattern as we did before, subtract 12 to both sides. I have x squared minus 4x minus 12 equals 0. Thinking of two numbers, when you multiply together, you have negative 12. And as you add these two numbers together, you have negative 4. So would -6 and +2 work? Once we have the factors, what are our x values? That would be x minus 6 equals 0, giving us the result of x equals 6. X plus 2 equals 0, giving us the result of x equals -2. Don't forget to do your checking by plug the values you calculated back into the equations. Have we forgot something at the very beginning as our restrictions? Can our x be -2? Of course not. X plus 2. If you have x equal to -2, it'll make your denominator equal to 0. So obviously, one of our answer, x equal to -2, is not okay. We have to cross it out. We have to exclude these values. You are responsible to get rid of this value. Even though we calculated it to be part of our solutions, it has to be written out. It cannot be included as part of your solutions.